In this series, I will focus on modern C++, which refers to the form of C++ programming which emerged out after the introduction of 2011 standard C++ 2011 standard, and which is still continuing to evolve. Here I will talk about auto keyword and range based for loop. Auto is a C++ keyword used to deduce or infer type of variable by the compiler during compile time. Range based for loop is an alternative to the standard for loop, a more readable alternative to for loop. The range based for loop operates over the ranges such as elements of an array or a container, which can be std array or std vector, etc. Let me discuss a little bit more about this through coding. I'm going to be talking auto keyword. This is the keyword which we can use to ask compiler to infer a type of a variable based on the value or data it is set to. For example, if I set x equals to, let's say, 5, then I can put keyword auto to ask compiler to infer the type. So now compiler will infer the type of this x. If I want to see first the value of x, and then after that type of x, you can use a function called type id x and call the function name through it. Will return an object, and you can call the name function through that object. But to use this type id, we need to include a library called type info. So this should compile. Let me do compilation of this code. So it is displaying the value data is 5 and type is I means this is for integer. So go back to the code, and if I have another thing, let's say y equals to, let's say, 33.33. So in this case the type should be a double. So instead of keep writing this, let me create a function that will receive a different type. So I'm going to create I'm going to be creating a template function. If you are not familiar with this topic, I recommend you to watch one of my previous videos in another series, which is C++ basics. So you can go and watch this video. I'm not explaining how to create template. I'm directly using it. This is a type parameter, void and print and type A. Inside I am going to be putting this entire code. So let me call this is not x, so I call this data, and this is going to be a, this is going to be a. So this is the function I have. I'll call that function from here, print x, and I can easily do the same thing for y, print y. So this should display the double, the type, this type id and name should display double as a type of this variable y. Main, you have this data and type is d is for double. Okay, going back to the core, if you want to, let's say, create a type, for example, let me have this instruction, p equals to, I want to initialize this to address of x. In this case, since this is the address, so it is initialized, so this should be a pointer type, right? So compiler should infer this to be a pointer. So let me see what happens here. Print p to the terminal. So you can see the data is this thing. This is obviously the address of that variable x, and this indicates p is for pointer, I for integer. So this is pointer to integer type, integer pointer type. So now, if I want to do info, I mean ask compiler to infer this variable for this data. Let me call this MSG, message or something, some string world, hello world, and print this thing, and go to the terminal. So now data is hello world and type is pkc. This is a p stands for pointer, k stands for constant, c stands for character. So this is a constant character pointer. So, and if you want to have a reference, let's say you can do something like this, auto reference, and then xr equals to x. So this will be the reference to x, and if you have auto reference yr equals to y, this would be the reference for the double type, I mean reference to x, reference to y. So if I display the data x and y, x, let me have xr here, xr, and yr. So it should display the data that is stored in x and y, and 33.33. So you can see the 5 and 30, because these are simply the reference to this data, and this is the outcome of the the use of reference to this data, 33.33. Now this is all I want to talk about, this syntax of this using this auto keyword. We will come across different situations where we will find it more useful. But next thing I want to discuss is range based for loop, where we will find the use of auto there. So now I'm going to be talking about range based for loop. This is a loop which actually offers easy way to iterate over the elements of an array or a container, such as vector, right? So we can use range based for loop to iterate over let's say an array, something like this. Int I create array using this way, 15, 25, 30, 10, 45, 60, 35, something like this. So this is this will create an array and initialize the elements to this values, and like this, or some vector. To use vector, we need to have include the library vector on the top, and we can create a vector, let's say of size 10 with data 6. In this kind of containers, and in this array, you can use range based for loop, and it is to be used when you don't need an index. For example, in for loop we have index, we can use this index you can go and select particular element. But if you, in a case where you don't want to use index, you don't have the use of index, then you can use uh, this range based for loop to make your code more simple, to code look more simple and clean. Typically it is used when working with containers, as I told earlier. Vector, and even you can use this with other containers such as list or std map or std set, etc. So I'm not going to go ahead and discuss this list map set. I will do that in one of the future recordings. Now I will use this array and vector to demonstrate the use of range based for loop. The syntax for this for of the range based for loop is for, and this is syntax which actually it borrowed from the non range based for loop or traditional for loop. But in this case, instead of having, let's say, int I equals to 0, this is a declaration, and I less than, let's say, 5, this is a condition, 6 condition, and then you have some thing to do some incrementing, some update of I. So this is object expression, this is a condition expression, and this is the declaration expression. In the range based for loop, we only have a declaration, we don't have this things, and we have a colon. Even in the declaration we don't have this initialization, we don't initialize. So, and then name of the array of container. So you want to use this actually this is a variable which will actually copy the elements of this array. So you want to use the name that is more aligned towards the name of the array. Maybe let me call ARRI index. Oh no, ARR. Let me call this element, right? So you can do use that element to display the actual element of the array. So, and if you want to display with the elements separated by space, you can do like this, and after that a new line character. So this is the syntax, this is a basic syntax, and this in each iteration the value of this array 20 will be copied to this variable, and it will be used here beginning from the first element to the last element. Let us see its output in the terminal. So we have this data array data displayed 20, 15, 25, 30, 10, 45, 60, 35. Going back to the code, when you have this element, the array is containing this kind of thing of simple values, numbers, then it's okay to do copying. In this case, the copying happens, data is copied. But if this we have an array, let's say of some user defined type, some integer or some vector, and each element is a very big size, it contains big data. In that case it is not wise to copy. It is always wise to um, have a reference here, declare this as a reference, so that this will be not carrying a copy of the element of the array, it will be just referring, it will be acting as a reference to the element of array. First reference to this element and reference to this element, and so on in each iteration, something like this. So in that case it will not copy, it will just go and access that element. And if you don't want this code in this place to make any changes, then you can make it constant reference. Let me do the compilation so that we don't have any issue with the code we have so far. So we don't have any issue with this code. Now And in sometimes, you may not know the type of the element carried by this ele- thing. For example, especially in the case of container, you may be using a container of this vector type, this type, map type, set type. So I mean, the container may be carrying the objects of types, let's say a student or some professor or something. So in that case, sometimes it may be inconvenient to go ahead and find out the types. So you can ask the compiler to infer the type, I mean, using the keyword auto that we discussed just before. This auto keyword, you can ask the compiler to infer the type. So using this keyword, you don't need to worry about looking into the type of the element. And you can use this auto in this way. It will be just simply integer, and then you can have a reference with auto, you can have constant reference with auto. So let me also have a code using this vector. I want to actually create a new vector. Let me have um, for actually this is not a correct syntax for creating a vector. If I want to create, I need to actually specify the type of the element here. In this case, it is going to be integer, right? So let me comment this out, and I want this vector to contain integer elements, and the name of vector is IVEC, integer vector. And I want to create this vector by initializing from this array, just copying this element. So the syntax for doing is name of the array, and this is the address, beginning address. um, I mean, this is essentially address of this first element, and the address of the last element, plus we have 1 2 3 4 5 8 elements, so plus 8. So this will create a vector, and then you can use for range based for loop. uh, Object iv back, and you have cout statement iv, this one. So this is this pretty much similar to the array syntax, but instead of array we are actually using the vector. Let us see the output. Was not declared. I think there was typo problem. Let me go back to the code. So it should be obj. So we have the same element displayed, but the vector contains its own copy. This is the vector doesn't refer to the original array which was used to create the vector. Array has its own elements, and the vector has its own copy. I mean, its copy of the its own elements. So this is all I have to talk about these topics. Thank you for watching this video.